Welcome to my shop. We've got a little project for the steam locomotive to get it ready for the operating season. I'll take you in real close and show you what we're doing here. In a previous video, we showed this dynamo operating. It puts out about 2.5 volts, which is just enough to run our cab lights. So we have a light for the water glass, a light for the main steam gauge, and then the headlight up front. This puts out an AC type voltage, so these LED bulbs can handle either AC or DC, which is really handy because I want to set up a battery system as an alternative to that dynamo. I found out that these dynamos are rather expensive, so I don't probably want to use that all the time. So I'm going to use a battery pack that fits back here with a little cord that runs up along and goes into the junction box. That junction box is another thing that I made out of a leftover journal box from one of my flat cars. And it has a little door, and inside of there is a little micro 2-pin connector that connects the dynamo with the whole lighting circuit. So I can unplug the dynamo and plug in the battery pack. So let's go check out the diagram I've made for the wiring. As you can see, I'm not a professional electrician, but here's my basic diagram. On the upper left is the headlight. Second thing from the left is the dynamo, which is an alternating current generator. Then in the very center is a single pole dual throw switch that lets me select between power source of dynamo or battery pack. We have 2 gauge lights and then the battery pack on the far right. You can see that the gauge lights are also connected to a ground, and those go back to the battery pack. And also the headlight is grounded to the frame of the locomotive. Also built into the gauge lights is a connection to locomotive ground by the side of the bulb socket. So we've got 2 good grounds there, and that completes the circuit to everything that needs it. Well, I finally finished the wiring on the little chooch. I would have liked to have you along with me, but you would not want to see me struggle the way I struggled on this project. So I'll bring you in close here. I'll show you what I've done. There's the headlight. It's quite bright. Just a 3-volt LED. It's a bipolar bulb, so it can run AC or DC, which is good because that's what my system has. I have a water glass light here and a steam gauge light there. The way that I made these light fixtures, this is just a brass pipe nipple, and on the front side of it, there's a slot machined in it with a 1/8 inch end mill and a flat machined where that slot goes to replicate the look of the little cast aluminum gauge lights that you would find on a steamer. And then just a simple brass bracket with a pinch clamp and some scale nuts around the top of the water glass. And that's just loose enough that if you hit it, it's not going to break it. You can swivel that a little bit. The conduit is just extension spring. And then I made the fixtures, these little bases, just out of brass hex stock on the lathe. That was mostly to mimic the existing ones that are on the locomotive. So these were my examples. And so everywhere that I did conduit, I have a finisher that's made that same way. I have even a connector there, more clamps. This one was a little unique. I had to have a junction. So I used a larger piece of hex stock with some machined little junctions there. This end piece is a cap that allowed me to get both wires to turn the corner to go into the fixture. That's really tight space there, and you can't really get them in without some end access. So that was a fun challenge. Then the bracket on that one just hangs out right on that steam pipe there. The longer the bracket, the better the heat dissipation. So hopefully these won't get so hot that they burn up my bulbs or wiring. So that gives you an idea of what we have here. Over here, I have a junction box right there. So both of these lights have a positive and a negative that are connected. It also turns out that the negative is grounded to the body, which grounds to the whole locomotive, which is how this Moseley generator is going to work. This one, and I think this is characteristic of all of his, is set up as an AC unit. This unit here is a 1.5 inch scale, and we've got our steam going to it, and I plumbed in a regulator to make it look like an injector, kind of, so it doesn't look so out of place. And on this particular locomotive, that's the best place for it. There's no real estate here. I could put it here, but there's a lot of heat from the exhaust. There's just no real estate on top of the saddle tank that worked well. So this makes for a nice short steam path too. So I made this little bracket that mounts to the steam dome, and there it sits. Now this grounds out to the chassis or to the locomotive frame, and then it's a single wire for power coming through. So that goes through the firewall. It comes into this junction box that I made out of a leftover journal box. The journal box is actually one of those, and I'd cut the wrong angle, and so I squared it off and made a little lid for it. So we've got power from the generator coming into the back of that box. They go to a little bitty 2-pin connectors, and I'll put the part numbers for those online. They're fairly reliable connectors, and they don't take up a lot of space because I knew I had very limited space to fit all that in there. In addition, we have a wire from the headlight. This is also single wire because it grounds out to the locomotive also. So single power wire. And I had to fish that through here because the original wire was a little bit too short to do what I needed. That comes up from the floor and goes into the junction box right there. Also, I have wires coming out the back feeding my 2 gauge lights. And in addition to the power wire, I've also got a ground wire because I need this stuff to eventually get back to a battery supply. So I have both power and ground. And it turns out it makes a big difference which wire on the bulb base is ground. And I'll tell you about that in a minute. And the last thing I have is an additional wire on the right there coming in through a conduit that goes down through the floor underneath. You can't really see it well. It's that gray conduit. Comes up to a flexi with a removable connector, back to another gray conduit, and back to my battery supply and my buck converter. And we'll talk about that in a minute too. The turbo generator worked just fine the last time I had it out, and I have a video clip that shows that. But the battery power is a DC setup. And so that comes with its own challenges. So I started taking this junction box apart and wired it up, and it worked fine in one mode. But then when I hooked up the ground, I had a dead short. And it took me forever to figure that out, about 4 hours. Finally, what I determined is that when I wired these gauge lights, they were initially wired for AC. And so I had just randomly chosen that the outside of the bulb base was going to be power and the inside was going to be ground on this system. And that worked fine because I had a ground wire that went to the junction box and grounded out to the box, and I had a complete circuit. Well, it turns out that when you hook up a DC power supply, now I've got a dead short because my power is grounding to the frame of the locomotive. So as soon as I touch the ground wire to the frame of the locomotive, dead short. And because that's not obvious looking at the outside of the fixture, I looked at all the other wiring and tested for continuity and resistance, and everything checked out, except every time I hooked the ground wire up to the locomotive frame, I'd get a dead short. I remembered Einstein's quote, "If you stare at a problem long enough, the solution reveals itself." So I stared for a good 4 hours. I finally took the fixture apart, which is just the way I've got it machined. I won't take it apart because it's kind of a pain, but there's a brass end plug with an O-ring that keeps this in place. So it makes it easy to remove without having to twist the wiring. And I finally pulled one out, and it was immediately obvious. I looked at the outside and went, oh, there's my problem. The outside is where the power was coming in, and that was also shorting directly to the frame. It was an easy fix. I just reversed the wires, and because these are dual polarity LED bulbs, they don't mind which way they get their power. Once I did that, I was set. The one last thing I did is I hooked up this little micro toggle switch. So I can switch in the up position, power incoming comes from that wire to the generator out front here. And when it's in the down position, the incoming power comes from my battery supply back here. So let's talk about our battery supply. This is just one of those little car jump starters that I found. It has a couple of USB outputs and a charging input. And what does it say here? It's a 5-volt output. You can choose between a few amps or a few more amps. It's pretty low. I think 1 amp or 2 amp, I think. Anyway, it's got a little flashlight. But you could use just about any USB power source. They have those little bricks with the solar panels. Just about anything will power this. With this buck converter, you can see I've got it programmed for about 3 volts, and all 3 lights are drawing about 0.16 amp. So not very much amperage. I think this is 10 amp hours. So you can go a long time on battery power for these lights. I made the conduit. Just happened to have this sitting around the shop. And I think it was some old brake line or something, maybe old fuel line in a roll. But you can make that out of just about anything. You could also use the spring stuff that I use here. I'll put the link to that on Amazon too. Let's take a tour of the cab while we're here. I don't think I've done that before. This is very typical of a little steam locomotive, even 3-foot gauge, full-size prototypes. This is a very common cab setup. So the main thing you've got is a steam gauge there. And you've got a water glass. Most locomotives nowadays have at least 2 water glasses. Some even have a set of tri-cocks. You try each position and you can see where the steam is relative to the boiler. They're usually positioned about 3 of them, about the same intervals as top, middle, and bottom of the water glass. We have our throttle. This is going to open a valve at the driest portion of the steam, which is going to be up in this dome. In this case, I think it's actually a front-end throttle because you can't get to this dome. On a prototype, you could remove the dome lid and the throttle. You'd either have a dry pipe and a throttle right here, or you'd have a dry pipe going to a throttle, which is probably the case for this little engine. Since there's no access there, you need access to the throttle to lap it in because it eventually gets steam cut and leaks. Also, we have our injector steam line. So this is a cheater valve. You just pull it and it comes open, which is kind of nice. It's a quick one. Normally on a full-size locomotive, you'd have to unscrew that to get steam to start your injector. And so this injector is a non-lifting injector. It's placed below the running board. This particular one is by Eccentric Engineering. It's their size small, which is ideally suited for this boiler. And the water control is right here. So out is open, in is closed. So to start that injector, you get a full blast of water. Add your steam. You'll hear it start to prime and take up. And then it'll shoot water into the boiler through a check valve that runs down the side and comes in. There's the check valve in there, and it goes into the boiler. It uses the velocity of that water with steam behind it to hit that valve and overcome the steam pressure, which is the very same steam pressure that's driving it, which is a really cool design. What else do we have here? We have a blower. I'll take you in close there. Blower. So you open that valve and that runs down through the boiler to a nozzle that's in the smoke box. And that creates artificial draft, and that keeps your fire going forward and not backward out this door. That's particularly important with propane on this locomotive. Propane's very gassy and it wants to come back out the door. So the blower, just a little bit of blower, keep it moving forward. On a coal burner, you can introduce artificial draft with blower and build steam faster than your natural venting through the chimney, or the stack as they call it. Same with an oil burner. The blower is good for that too. You can, if you're a little bit behind and you need to catch up quick, you can put a little blower on and that allows you to burn more fuel than would normally be able to burn with the amount of oxygen you have available. We also have a firing valve here. That's an extension handle that operates a needle valve, which is very hard to see below the cab. There's a secondary needle valve here for a single pilot burner, so I can let it simmer without having all 6 main burners on. Those all are fed by this propane supply. There's a safety valve here, an additional hose, and that all goes back to the regulator and my fuel tender car. And there's a whole video where I built that and explained the function of that. We also have, we pointed out our water glass, and then there's the blowdown valve and the shut-off valves to the boiler. So when you start a steam engine up and you get some steam pressure, you always know where your water glass is, but you also want to blow it down occasionally to make sure there's no minerals or clogging that can occur in the valves going to the boiler. You can imagine what would happen, especially on this bottom one. If you have a clog here, this water in the glass is not going to be able to drain and equalize in real time with the boiler, and you could get a falsely high water indication. You might believe you've got a half glass when in fact half an hour ago this dropped down out of sight, and you're in big trouble. So it's important to blow these down just like in the full prototype. I should add that it's equally important to have the top one blown down, because if you don't get any steam pressure to the top of the water column, the pressure from below will push the water up in the glass and also indicate a false high level. The way you do that is you've got your drain shut down here, and you shut these valves and you open one at a time, and you confirm. You'll hear the steam hiss when you open this top one, then you close it, make sure that everything shuts off, and this will be empty. Then you open the bottom one and you'll get the water hiss, and you'll see kind of a watery thing going on here. You close that. Then you close your drain and you open up your water below, and you'll see the water go whoop. Then you open up your steam and you'll see the steam equalize and go whoop back down to whatever your level is. And then just to confirm, you can open your bottom drain again and blow that all out aggressively, close it, and make sure it equalizes. So let's talk about how the electronics work on this. The primary source of power is this Moseley MO-6 turbo generator. It's made to look like a Pile National from a full-size steam locomotive. If you have a second glass, you do the same thing, and you look over and make sure the two are in agreement with one another. That's the way to blow down your water glass. And for this little engine, we only have a single way of taking care of that water. So I blow it down quite a bit. I want to make sure I know exactly where it's at. Because of the position that you ride this, there's a mirror. So I can adjust that mirror, and it's a little bit loose. I have to tighten this nut here, but when you adjust it, you can see in the reflection the water glass, because if you're sitting above it from the engineer's position, it can be hard to read that in real time without ducking down, getting your eyes on it. In addition to the injectors, we have 2 more ways of putting the water in the boiler. We have a hand pump, and that works fairly well. You don't really want to use that going down the road because it takes some time. It's better to use an injector or the axle pump, but it does work. I use that more if I'm steaming up and I want to bring the water level up a little bit, but I don't have enough steam to run the injector. Additionally, I have an axle pump, and there's a bypass circuit. So if you open the bypass circuit, the pump doesn't really push against anything. It's just the water just goes in a circle. In fact, you can even shut off water to it, and it's not doing much of anything. The pump is still moving, but it's not pushing against anything. If you want it to work, you can change that bypass circuit where you shut off the bypass, and it will force it to go up through the check valve on this side of the boiler. There's the check valve there. That check valve is plumbed common to both the hand pump and the axle pump. And you have an option. You can draw from the saddle tank, or you can draw from this tender, or you can draw from both. You can open them both up and get water from both locations evenly. I tend to leave this one full because I like the tractive effort of that extra water weight over my driving wheels. And then I draw from this rear tender, which is also just as good. And since I'm sitting on this, I don't have to worry about that losing too much weight. That pretty much covers the plumbing on this locomotive. Oh, also the reverser. That's real important. So right now it's in neutral, and then you can change, that's reverse, that's forward, and you can hook it up by a couple of notches each direction, and that helps economize steam use, and it changes the valve cutoff, so you get less steam the further you hook it up. There's less of a port exposed because it changes the geometry of the valve gear. And that's good when you get up to higher speeds. You don't really need a full hit of steam, full valve exposure. You can hook it up and you just get little sips of steam, which is good when you're running faster and you have that momentum on your side. But sometimes, if you ever watch engineers, they'll get to a steep hill and sometimes they'll bring it back. You know, they may be hooked up here in the middle of the company notch. Sometimes they'll have to notch it down a couple notches so that you get a little bit more power from that steam. It gives it a larger opening, bigger hit of steam to the cylinders. Normally, you would see the flues, but what we're looking at inside here is an arch plate. It's a steel plate that forces the fire to hit that plate and go up, back toward this back head, and then forward. And the purpose of that is to create a longer flame path in this firebox, so we get better heat transfer to the crown sheet, which is directly over this, and there's water on the other side of that crown sheet. So it gives you better heat transfer instead of your flame just immediately shortcutting through the flues and out the stack. So you don't lose as much heat when you have an arch like that. Some locomotives don't need it because they have good heat transfer, but these little boilers with these tiny fireboxes need a little bit of help, and that seems to make all the difference in the world. I think this firebox is only about 5.5 by 5 inches square in dimensions. So that whole assembly bolts up into this pan. In fact, you can see the plumbing for the burners here. We've got the auxiliary single burner here, and the main burners come off a manifold that I built right here. The manifold is 2 legs that stick forward and 3 burners each side that oppose one another at about 90 degrees, maybe a little less than 90 degrees. And the air flow, I have not messed with at all. They say in a lot of the books you want it slightly restrictive relative to your flue area. So I did some calculations and it appears to be slightly restrictive. I've never had to mess with it, but it steams like a house on fire. And you can, even if you're a little bit behind on a hill or something, you just crank it up and it doesn't even really run rich unless you really get extreme, but it seems to have plenty of air to breathe, and it'll make steam and water as fast as you need it. We've got a oversized whistle here. It's a little big for the scale of the locomotive, but presumably they could have taken it off an old ship or something. But what you have to realize is sound doesn't scale. So a little bitty whistle, like would be a scale 1-inch whistle or something on this locomotive, doesn't sound good at all in real life. It's more like a dog whistle. And there are a lot of older people in the hobby that would never even hear it. They'd run you over with their car or something. It's important to have some kind of sound making device for safety. There's my valve in the dome. When I'm steaming up, I open that up and it'll start to spritz water and steam when you have steam on board. Then you close it off. That helps let some of the oxygen out, which is easier on the boiler. And then 2 safety valves. These are set for 120 psi and one is slightly above that, I think. So in theory, you can't defeat those with the biggest fire that you have in here. They're supposed to vent that boiler in excess of the amount of heat you can make with your fire, so you never exceed the rating on the boiler. Here's the fill hatch for the saddle tank. We have a bell. You can tell the bell doesn't scale well either for sound, so I don't really use that. There's our headlight. I've got a stack cover. I bought this at a craft store. It's just a fun little kind of a jar lid. It's not really threaded, but I'll show you where else I use this. Just as a little aside. Right there, my fuel selector for the 38 MG. You can see videos on that car too if you're interested. There's lots of detailed videos. Anyway, I happened to buy two, and it made a great stack cover. It looks good. Some other details. We've got the cylinder cock linkage, which is controlled by this lever here. So when I pull that lever, you can see the linkage move. It opens up the cylinder cocks or the cylinder drains, and it lets water out. That's really important because when this is warming up, you're still getting a little bit of steam bypassing the throttle, and it comes in here and condenses. And if you try to move this engine with water at the end and no drain, water doesn't compress real well. Something's got to give. In this case, the locomotive isn't powerful enough, but on a full-size locomotive, you can just blow the cylinder head right off the end, and then you're done for the rest of the week while you try to patch that together. In this little engine, it just hydrolocks and doesn't go anywhere because there's not that much power, and it's not super high-power steam at 120 psi with these little pistons. I'm sure you could still hurt yourself if you did some dumb things with your hands, but it's not going to blow the cylinder head off. So you open those up, and you run the locomotive, and you kind of watch the stack because the exhaust is going to tell you how dry that steam is. And once things get warmed up, you'll stop seeing quite so sloppy of an exhaust. It'll get a little bit clearer, a little less watery. And you'll notice that the hissing comes out more like steam instead of real wet, saturated, watery steam. And at that point, then you can close your cylinder cocks. But I usually open them every time I stop. Also, that limits any throttle linkage from making the locomotive move because you don't want that to happen by accident. Some other details. On a Hawaiian sugarcane hauler, it's not often that you see a flanger, but this flanger is here for more than decorative purposes. This is actually a crash bar, and you'll notice that it's just below the height of these fragile brass cylinder cocks. So if this engine goes on the ground, there's not enough clearance for these cylinder cocks to clear the rail, because one side or another is going to end up hitting rail, or if you split a switch, it's going to just wipe those right off, and then you have to get an easy out and pull the broken threads out of the cylinders. It's a major pain. So I've learned from experience of other people that that's not something you want to mess around with when you're trying to have fun. So I built this crash bar, and I know it works because I split a switch the first day I ran this, and it saved me. It went right down on that crash bar. The crash bar is welded to these blocks that attach to the frame with these screws. So it's very solidly built. There's a piece of wire in there. That's part of the old headlight wire that I redid. There's a front coupler. They're functional. You lift the pin with either the chain or your finger. They work. They're very prototypical. These bars here you can hang on to and ride the pilot in the old days. You can't do that nowadays. Can't ride it going forward. But they'd ride up here, and they'd have little sand buckets, and they'd dump sand on the rails if it got really slippery. And they still do that. I think there's a guy in Indonesia that shows, it's like 20 guys on the crew and little locomotive, and they're doing everything they can to get it through these sugarcane fields to harvest sugar. I have foot pegs on here. When I got the locomotive, they were mounted to the tender, but the tender doesn't need any extra weight on it. That doesn't do us any good. I'm already sitting on that. And, you know, the only advantage to weight on the tender really is the efficacy of this handbrake. But I'm sitting on that, and they work just fine. So I moved them to the locomotive. It also puts them a little further forward and allows me to get my legs in there because I've got longer legs. They have motorcycle-style sprung pegs, so if you hit something or if I have to move it into the truck and it's a tight clearance, these will fold back, which is a nice touch. There's the other water valve in the tender that controls the water going to this tube for the axle pump or the hand pump. The tender itself, got a little seat here that I made with a cutout for the water filler. There's my battery pack and buck converter, and at some point I need to build a little container for those because naturally you're going to overflow the water and it's going to spill down onto your electronics. So I'm going to build a little box for that, maybe just a little Tupperware bin that they sit in with a grommet for the wire. And then I drawbar this out with a drawbar that hooks to my auxiliary tender with the propane fuel source. And then I can put tools on board. Have a toolbox, fire extinguisher, all the things I need. There's several emergency shutoffs for the propane fuel source. And then behind that are the rider cars. And there are videos that cover all that stuff. So we're planning on taking this out to the operations meet. And in past years, we've always used the electric goose. And this year, we're going to challenge ourselves. We're going to do it with steam. And the way we're going to do that is we're leaving the goose at home. Yeah, you heard that right. We're leaving the goose at home. The goose has never missed a meet. But we're going to try to do it with steam. And if we break it, we'll fix it because that's how they are. But we shouldn't break it. I don't think we're going to have any issue there. It's pretty solid. Oh, let's look at this. See, it says cylinder oil on it. You see the lever goes out to the valve gear linkage. So as that rocks back and forth, it causes this to move. Of course, I can't move it because everything's stopped, but that pumps cylinder oil into this tube, and it goes down into the valve chest, and it lubricates the valves and then gets carried into the cylinders. So that's something you never want to let go dry when you're operating a steam locomotive. The full-size prototypes have what they call a hydrostatic lubricator that would be set up in the cab. And it would have sight glasses and a little control for feed rate of so many drops a minute. It's usually like 3 to 4 drops a minute. And it uses a condenser where the steam condenses to water, and then that sight glass is in the water, and you'll see the oil droplet escape from the nozzle, and it'll rise up to the top, and then it goes through a pipe, and then once it hits atmospheric pressure, it becomes steam. So you'll see a little puff of steam usually coming out of the cylinder cocks, or there'll be a snifter valve. I don't think this has snifter valves, but on the full-size ones, there's often a snifter valve of some kind that drops down when there's no pressure in here and vents out any passive leaks or the accumulated hydrostatic lubricator steam. They also have mechanical. So some locomotives never had hydrostats. They went straight for mechanical. And a lot of that was builder and mechanic preference. We can take a look at the running gear here. This is Stephenson valve gear, which you can't see because it's inside. But it's hard to see, but there's 2 eccentrics on each side, giving you the forward-backward rocking motion. And then the link is back there. And then from that rocking motion, it imparts a valve motion here. And that's adjustable with that reverser lever that I showed you. So I'll move that reverser lever, and you can watch how it changes. We're going to reverse here, down to forward, reverse, forward, and right in between, centered. So that's how you control direction and valve stroke. And then, of course, everything that wiggles has an oil cup. So there's an oil cup, and there's an oil cup. And if it doesn't have an oil cup, it's got a pinhole that you oil. And if it doesn't have that, you still oil it, because anything that's a pin that wiggles needs oil or it's going to wear out. Because these things are wiggling back and forth like a sewing machine. I've got oil cups there. Crosshead. There should be something for the wrist pin. That's one of the most important parts of this whole locomotive, because all of the force has to go through that before it gets there. So what I do is I just stick the neck in and I drizzle that in. And that's the only way to access that. Same with the eccentrics. There's a little cellar. Let's see if I can get my finger back in there. There's little cellars on the backs of the eccentrics, because those are running around an eccentric guide on the axle like this. And as the axle is spinning in place, the eccentric is doing this on the axle, and it's riding on that. So that needs to be lubricated. Even the leaf springs, they need to equalize. So you can see there's the equalizer right there. It's like a teeter-totter. There's the pivot point, and it runs to the bottom of each of these leaf spring packs. So when you go over a bump, it equalizes that force over to the next axle. So all of that has to be lubricated too. There's washout plug there. There's another washout plug up under here for the rear of the firebox, the mud ring. Here's a blow down so you can blow scale and change your water over. It's important because you're boiling water and you're leaving the minerals behind when you boil water. So if you continue to do that and you don't have boiler treatment and you don't flush the water out occasionally, you're concentrating all that mineral and it's going to end up hurting the boilers. I use a boiler treatment that solubilizes that mineral stuff, and then you blow it down and all of that stuff that accumulates from the solubilized mineral will get flushed out, and you can continue to refresh your water so you don't concentrate minerals. Mineral concentration can be hard on the boiler because it can change pH and chemistry, which can harm the metal. It can also cause minerals to accumulate on the surfaces, and that hurts heat transfer. If the outsides of your tube, which are on the water side of the boiler, get too much mineral, you're going to lose the ability to transfer heat, and particularly back here at the crown sheet. We want to maximize that heat transfer by reducing the amount of scale that builds up in the boiler. Well, let's do a night demo. That's going to be fun. I'm going to turn the lights off in the garage, and we'll see how bright that headlight really is. It's bright enough that I can see my way through this garage. Let me turn off my shop light. That's all locomotive there. So at night, that's plenty. If you didn't have a bandsaw in the way, that would cast a nice beam. And then if I see an oncoming train and I don't want to blind them on double track, I can hit this switch and momentarily turn them off. I don't have a dimming feature because it's important to run a constant load on the dynamo when that's running. It's a very basic wiring setup here. There's a water glass light and a gauge light. These are especially handy even in the daytime because this cab can be a little bit shady if you're in the woods. It might be kind of hard to see those gauges. Just like with the full-size prototypes, it's important to have gauge lights on all the time. And then you can see my battery supply. It's got a cool glow. Well, that's about all for now. Thanks for watching. Appreciate the subscriptions and the views and the comments.